Hi everyone, this is Kona, and I'm going to talk about the 5-number summary. So just a brief introduction. It's a standard way of displaying the distribution of data, so how data is spread out, how it's distributed in regards to what your values are. What are the 5 numbers in the 5-number summary? You've got your min, which I know that doesn't look like it, but it is min, your Q1, which is your first quartile, your Q2, which is your second quartile, and it's also your median, your third quartile, and your maximum. Now for the quartiles, the first one is 25%, so it's the first 25% of your data. The second quartile is 50%, so that 50's chunk of your data, where 50's on one side, 50's on the other. And the third quartile is 75%, so the 75% of the data. Min is the lowest number and max is the highest number. Your interquartile range, or your IQR, is the middle 50%. So in contrast to the Q2, which is the 50% mark, this is the middle 50% of the data, so that would be 25 on either end. And to find that, you take the Q3 minus Q1. Your range is your maximum minus your minimum. And then you have a lower outlier cutoff, which is Q1 minus your IQR times 1.5, and an upper outlier cutoff, which is your Q3 plus your interquartile range IQR times 1.5. The lower outlier cutoff and the upper outlier cutoff are basically the lowest value and the highest value that you could have, and it still be kind of reasonable. So anything lower than this value or higher than this value, and you would think, that doesn't seem quite reasonable to fit with my data. So moving on to an actual example problem. So in this example problem, we've got the following data: 63.2, 60.4, 60.4, 62.7, and 62.6. So the very first step is to put it in order, and that's always the first thing you should do, is put it in order from lowest to highest value. So 60.4, 60.4, 62.6, 62.7, and 63.2. So there's total of 5 numbers, so n is equal to 5. And then also you can see I've got this little 1, 2, 3, 4, 5 where I've numbered these. And that will come into play when we're trying to figure out our quartiles, or if we're trying to find the number in a certain position. So once we've got them in order, the next is and I've got mix, but it's min and max, where our minimum, our lowest value, is our 60.4, and the maximum value is 63.2. So there's our maximum. So to find that first quartile, which remember is the 25% of the data, you would have 0.25 times n plus 1. So what's the n? The n is right here. There's 5 numbers, so 0.25 times n plus 1 is 0.25 times 5 plus 1, which is 6, and that's 1.5. So 6 times 0.25 is 1.5. So what do you do with this 1.5? And this is where a lot of people get confused. The 1.5 is in regards to the position of the data. So the position of the data, this 25% is halfway between the 1 and the 2, because it's a 1.5. So up here you see the 1 and the 2. Well, 1.5 would be like this middle, right here in the middle there. And so what we need to do is find out what value falls in between 60.4 and 60.4. Well, common sense is it's 60.4, but if you had different values, this is where you would solve it out. So what you would do is you would add the first value and the second value, so 60.4 plus 60.4, and you would divide it by 2. And in this case, we got 60.4, but the important thing is that you're adding the first value and the second value and dividing it by 2. And the reason you're dividing it by 2 is that it's halfway. So the 0.5 is that 50%, that's that halfway point. So that's why you can divide by 2 to get your 60.4. So for our second quartile, which is at the 50% mark, we've got 0.5 times n plus 1, which is just 0.5 times 5 plus 1, which is 6. So 6 times 0.5 is 3. So for this case, we're looking for what number's in the third position. So 1, 2, there's our third position, and it's 62.6. So in this case, 62.6 is our Q2, or our median. Now for our third quartile, we're looking for the 75%. So 0.75 times n plus 1, which is equal to 0.75 times 5 plus 1. So 6 times 0.75 is 4.5. So we're looking for a number in the 4.5 position, which is going to be the number right in between the 4 and the 5 up here at the top. So the 62.7 and the 63.2, we want the number right in between those two. So what we're going to do is add the 62.7 plus 63.2 and then divide it by 2, and we get 62.95. So there's our third quartile. So going down, our IQR now we can find by taking our third quartile minus our first, so the 62.95 minus 60.4 to get 2.55. Our range, which is just our max, minus our minimum number to get our 63.2 minus 60.4, which is equal to 2.8. Then our lower cutoff, which is our Q1 minus IQR times 1.5. So 60.4 minus 2.55 times 1.5 is equal to 56.575. And then our upper cutoff, which is equal to our Q3 plus IQR times 1.5. So 62.95 plus 2.55 times 1.5 is equal to 66.775. So there's the different numbers that we would find. But I went ahead and I included these two examples as well, just because I think they'll help you in the long run. So the first one is mid-quartile. The mid-quartile is not the median, it's not your Q2. It's a completely different number that's found by taking our Q1 plus Q3 and dividing it by 2. So in this case, our Q1 is 60.4 plus 62.95. Divide by 2, we get 61.675 as our mid-quartile. Also, if you ever see a question or anything where it says find the number in position, for example, 3.46. So if it's the number in position 3.46, we know it's going to be the number between 3 and 4, and it's not 50%, so we can't divide by 2 because it's 0.46. So then the question is, what do we do with it? Because we can't divide by 2. We don't know, we do know the total number, but kind of the easier way to do this, first of all, we're going to ignore the 3 because we know it's going to be between these two numbers, and instead subtract these two numbers. So take the bigger one, the 62.7 minus 62.6, so 62.7 minus 62.6, and then multiply that by the 0.46. So we're getting rid of the 3 because we just did that subtraction of the third and fourth number. So if you multiply that out, you get 0.046. You then add the 0.046 to the lower number, the 62.6, the one in the third position. So 62.6 plus 0.046 is equal to 62.646, and that would be the number in position 3.46, so the number between 3 and 4, so the number 3.46 on this in this data set would be 62.646. So the only other thing to cover really quickly is the box plot. So for the box plot, also called a box and whiskers plot, you've got your minimum number, which is this one right here. Then you've got your Q1, Q2 in the middle, our Q3, and then our maximum. The IQR is this chunk right here between the Q1 and the Q3. Remember, this is the middle 50%. Our range is our maximum value minus our minimum value, so there's our range. And then you've got an upper cutoff of 66.775 and our lower cutoff of 56.575. So pretty much as long as the number falls between the 56 and the 66, you know it might seem reasonable. But if it falls outside the 66.775 or outside over here on the 56.575, you would know it's probably not a very reasonable number. So I hope this helps, and if you have any questions, please let me know. Thanks.